Hi, welcome once again to the channel, and we'll continue with our naming of what compounds. In our last class, we looked at certain things that are very important for us to know before we can name compounds. We look at what the atom is, what atomic number is, what ions are, what valence is, what makes an atom stable, how to write electronic configuration. From that, we're able to get our valences and get the ions and all those things form. We got to the place where we had to write down the chemical formulas of compounds. We're able to write down the chemical formula. So when the compound is given to me, I can write down or I can form a compound. But today we are going to learn how to write the chemical formulas of the compound and probably also name some of the compound now. So now that we are set with the basis, we can move straight into it very, very quickly. Now, writing the name of chemical compounds or chemical formulas, want to write the name of chemical formula before we learn how to form the formulas or how to write down the formulas. So information of, let's say, aluminum chloride, we have Al3 plus and Cl minus. We said for these guys to come to, or for it to form a compound out of this, we interchange their valence. This one's the valence of 1. So we interchange the valence here and this one's drop. So we are going to get Al then Cl3. The one drops here, but they can't cancel, so we leave it that way. So we'll just write this. So this is AlC3, aluminum chloride. But this time we are going to look at how to name such a compound. How to name it. So if I give you this, if I give you something of this sort, Na2SO4, SO4, how would you name this? What's the name of this compound? So that's what I'm going to do today and go into what? Into more of the namings, more of the naming. Good. So here, like I said, we are going to write down the name of the chemical formulas before we go into the proper naming of the chemical formulas, where we deal with what? With the oxidation states and all that. Okay, so let's go straight into this. Now, if you want to name the compound, let's say I want to name this guy. I want to name AlCl3. AlCl3. I want to write this guy's name. Now I have the formula. I want to write the name. Now, the first thing I'll do is that before I even do this, let me put this one under the binary compounds. When I put this one under binary compound, it will make work easier. So there are certain things we are supposed to know that in a compound, the first element is mostly a cation. The first element is mostly a cation. Then this guy is what? It's an anion. You know what cations and anions are by now. So the first element in a compound is mostly what? Cation. And the second element is mostly an anion. That anion can be a single one, or it can be grouped. Now, when they are grouped, we call them what? Radicals. So there's this you have to know. That what? Radicals. When we say radical, what are radicals? They are a group of what? Of atoms with a single what? Charge. They are a group of, not a single one like Na plus. Na plus is what? It's a single ion. But we have a group of atoms that will come together to give us what? To give us a single charge. And we call them radicals or polyatomic what? Ion. So listen, polyatomic. That means most atoms came together, they formed that, and we have an example is what? Is this. Now all the tables are in the note. I'll get to them soon. An example is this. So SO42 minus is what? It's a radical. NO3 minus is also another radical. CO3 2 minus. So you can see group of them, or this group, this and this, they all carry a single charge. The charge belongs to the compound. It belongs to the radical, not this. It belongs to it. I'll go deep into that, you understand. So before we can write down their names, then these are the things you have to know what the radicals are. What are radicals? I said radicals are a group of atoms with what? With a single charge. So the point I'm making here, let me clear this one, that we want to name the compound. In a compound, we have two parts. We have the cation part and the what? And the anion part. Now, in the cation part is always a positively charged particle, which is or atom, which is what? Which is the Al we have here. But when you come to the anion, it can either be a single guy, like we have chlorine here, or at times they can be grouped like that. I hope you get the point I'm making here. Now, the formation of this is basically Na plus and SO42 minus. So this is how this thing was formed. Then because these guys are carrying a single unit, they drop this charge here, and this also drop the one. So that's how come we got Na2. The 2 is coming from this, then SO4. So this is what happened. The negative and positive will take them. So this is how I got this. So one thing you should understand here, of which you have to learn that is what is the radicals or the polyatomic. What are they? And once you know them by their trivial name or their conventional names, and we go. So if you look into the notes, let's go into the notes. I want to skip the first one and teach you this one before I come to the naming in general. Okay, now if you look into the notes, we are saying that we have what? We have the molecules. So if you have a molecule, like, what are molecules? Molecules is a combination of two or more atoms. They can be the same or they can be different. The elements that are combined in a molecule, hydrogen is a molecule, oxygen is a molecule, H2O is a molecule. But if you're looking at same molecules of the same base, then these ones are there. And for those ones, they are normally in the what? In the second, or they are normally the anions of the second part of the chemical formula. So these, like this, chlorine is a molecule. When a molecule, the name of the ion becomes, so hydrogen becomes so hydride, oxygen becomes oxide, sulfur becomes sulfide, fluorine becomes what? Fluoride, chlorine becomes chloride, and nitrogen becomes what? Nitride. So these are what you are going to encounter. That's why we have a table there for you to know the molecules and their ion or the names of those ions. When they form their ion, the names they get. Hydrogen gives what? Hydride. That's H minus. That's hydride. Then O2 minus is what? Is oxide. So these guys, these anions, which are normally found here at the second part in a chemical formula, this is what we have there. Then we go to the what? The radicals. Then I said radicals, these are a group of atoms with a unit or single charge. They have a single charge. The table for the radicals are there, and you have to know them. Once you know them, we can go straight away and look at what we want to do here. Because from here, I'm going to oxidation state. But for you to understand oxidation state, the radicals must be, your radical number must be sharp, must be correct, must be on point. So if you know the radicals, you have to take that and go to the radical. I said we have sulfate ion SO42. Let me mention them with you briefly. And we go through, so that you can also go and sit back and go through them. Now, I explained to you, before I even go there, I explained to you that when I have aluminium, let me use magnesium. I've used aluminium for long. Let me use magnesium, Mg2+. When I'm using this, when I pick just the number gives me the valency. The valence, which is the combining power. So you see that when this guy wanted to combine with this, he had to bring down, you brought down your 2, and this one gave you the 1. This is the valency. But if I take 2+, it's not the valency, it becomes the oxidation number, oxidation state or number. And that is the charge an atom will carry in its free or pure state. Before we can name the compounds, we need these oxidation or numbers. Very, very important. We need these oxidation or numbers. Hope you get the point I'm making here. Good. So, what are we saying here? We are saying that in any chemical formula, there are 2 parts. We divide to anion and what? And cation. But one of the things we need to know are the what? The radicals. And so in the table, I want to go through the radicals, oxidation number, and state with you so that you get to know it properly. The radicals, oxidation state, and what? And valency. So let's go back into the table and look at that. Let's go into the table and look at that. Let's go into the table and look at that. Good. So in the table, what do we have? We have radicals are a group of atoms with a single charge or with a unit charge. And we got the name of the radical, the name, the oxidation state, and the word valence. So look through and let's go very fast. We have SO42-, and that is sulfate ion. The oxidation number you can see is 2-, but the valency is just 2. Take note of this, it's very important. Because in any case, when we are going to form them, we change our valency. When we are going to balance the equation 2, we have to open up. You understand? When we open up, you go with whatever you contributed it. You take your combining power. When we separate we separate them so that we can balance chemical equations. So we'll also do that. Okay. So let's continue. Let's continue here. Good. So what do we have here? We have sulfite ion SO3 2-. We have NO3- nitrate ion. You can see the oxidation number is -1. Then we have nitrite ion NO2-. Nitrite ion oxidation number is 1. Then we have ammonium ion NH4. Don't confuse this ammonia. Ammonia is NH3, But NH4 plus, NH4 plus is what? Is ammonium ion. This is a radical. The overall charge this guy carries is what? Is +1. Good. So let's go. Then we have carbonate ion, which is CO3 2 minus. Then we have hydroxide ion, which is OOH minus. We also have hydrogen carbonate ion, what we simply call bicarbonate, and that is what? That is HCO3. And if you listen to this is the state in which carbon exists in what? In what hydrogen carbon cycle? It exists as HCO3 minus or bicarbonate. Good. Then we have phosphate ion, which is a PO43 minus. We have permanganate ion, which is MnO4 minus. Then we have chromate ion, CrO42 minus. Then we have dichromate ion. These guys I'm mentioning are all radicals, and we are going to see them. So you have to sit back and know all the radicals before you can use them. And I made mention of oxidation number. Now, if we say oxidation number or oxidation state, oxidation number, what is it? Now, oxidation number is the charge an atom carries in its free state or compound state. The definition again, I said, is the charge an atom is carrying or an atom has in its free state or in its compound state. What do I mean by that? Now, remember that before you form the compound, you had a charge. If you're an atom, Al and Cl will never form compounds because they are atoms. They can only form a compound when they are what? They are ions. So Al3 plus and Cl minus can form a compound, but in this the atom state, they cannot form. But they don't have any valency to interchange. Hope you get the point I'm making here. Good. So that is very, very important. That's very, very key. Very, very key when it comes to what? When it comes to this. So I'm saying that oxidation number is the charge an atom carries in its free state or compound state. If you look at the examples we have there, if I tell you to find the oxidation number of hydrogen, in this state, hydrogen is free. So since hydrogen is free here, then the oxidation number of hydrogen there's nothing here, so it's 0. The question given to you gave you this is 0. But if the question gives you this and they put plus here, then the oxidation number for hydrogen is plus what? 1. You don't go and say that because they didn't write that, no, hydrogen is plus 1. No. Follow what is given to you. Yes, we know chlorine is C minus. But if you are supposed to find oxidation, we're giving chlorine. Because the question didn't put anything here, chlorine's oxidation number is what? 0 for this. But when it is in this case, chlorine's oxidation number is what? Is minus or 1. Hope you are getting the point I'm making here. So don't say that you know that oxygen should be 2 minus. Hence, when you are giving this to give oxidation number for oxygen, that means 2 minus. This is wrong. There's nothing given here. So oxidation number becomes what? 0. Hope you get the point I'm making here. Good. Now, these are oxidation numbers of single elements. But how do we find oxidation number in a compound? Listen, note. I'm going to read a note and explain it. Note, in a compound, the oxidation number of an element is what? In a compound, oxidation number of an element is its charge. No, note, in a compound, oxidation number of an element is its charge. So in a compound, if we have SO42 minus, the oxidation number is this. That's what they are trying to say. That the number here is the oxidation number for this compound. Then the second note, once again, the compound, the sum of oxidation numbers or the sum of the oxidation numbers of the individual. This is where we need to take note of. This is what we are going to use in writing the names. If you can't find oxidation number, there's no way you can write the names because we need to find oxidation number of particular elements and work there with them. Hope you get the point I'm making here. Yeah, very important. Very, very well. Very, very important. So let's go. So we are saying that in a compound, the oxidation number of the sum of the oxidation number of the individual elements in the compound equals the overall. Let's say it again. In a compound, the sum of the individual oxidation numbers of the elements present equals this. That means, for instance, if this guy's oxidation number is X, if it is X, and that oxidation number is Y, then when I sum X plus Y, how many Y's do I have? I have 4 of the oxygens should be equal to negative 2. This is what I mean. The sum of the individual oxidation states If X is the oxidation state for sulfur and Y is the oxidation state for oxygen, then when I sum them together, I give the total oxidation state the compound is carrying or the compound has. And in this case, we have 4 of the oxygen. That is why I said we have 4 times what? Y. So you take note of what? Of that one. Right? Take note of that one. Okay. So let's go on. Let's move on. So now that we found how to find oxidation numbers here, let's try and see how to find oxidation numbers when it's in the what? In the compound state. Now remember, this is one secret I've also come to tell you. Now, the moment you are in a compound, I can tell you your oxidation state. Listen. If I have hydrogen here, I cannot tell that hydrogen is plus or minus unless the question has put the plus here. Then I can tell that hydrogen is plus, but plus 1. But the question write this, I will not force myself to say this. But we know, and I've told you, that hydrogen and chlorine cannot form what? Cannot form a compound unless they are in what? The H plus and the Cl state. So the moment I have H plus and Cl minus, I know your oxidation state in the compound. Whether I like it or not, I know. Because the moment you form a compound, that means the oxidation number must be present before you form the compound. So for this in a compound, I can tell that hydrogen's oxidation number is 1, and this guy's one is 1. I can tell that because this is in the compound. But if it's a load, I cannot tell. The question must tell me. I don't know if you get the difference here. But in a compound, before you can form that compound, you need to have your oxidation number so you can interchange your valences. So if you don't have that, then you can't form the compound. But once you have formed the compound, then I know your oxidation number. I know your oxidation number. Okay, so let's try this and see. So I want to use this as an example. SO4 2 minus. SO4 2 minus. I want to find the oxidation number for sulfur, the underlying one which is sulfur. I want to find oxidation number for sulfur. Now, to find oxidation number for sulfur, which is underlined, we said here that in a compound, the sum of the individual oxidation numbers equals this. The sum of the individual oxidation numbers. So here, say, let the oxidation number of this one be X. We don't know. So we want X to represent this guy's oxidation number. So X will be plus, because this 4, because oxygen is in a compound, we know, and you should also know, that its oxidation number is 2 minus. How do I know it's 2 minus? When I write the electronic configuration of oxygen, which is 2,6, you see how I'm connecting the thing? Electronic configuration of oxygen, which is 2,6. I know it needs 2 more, so that becomes its oxidation number. So in a compound, I know this. And this one should be equal to -2, and this -2 is the overall. Most students confuse themselves. They think this one belongs to this. No. You should know that since this one is from a compound, then it brought it or it 2 minus. But this 2 here is for the overall charge. So let's find X here. This will be X minus 6 equals what? X minus 8 equals -2. We'll have X equals -2 plus what? Plus 8. So X will be equal to plus 6. So this is the oxidation number for sulfur in what? In sulfate ion. This is what I meant by. So anytime I find an oxidation state or oxidation number, make sure that the one that is not underlined, you know that person's oxidation state. So far as you are in what? You are in a compound, we know your oxidation state. Very, very, very important. Very, very well important. Okay. So let's go. Now let's try another one. We have some examples here. Let me try them. So let me go with MnO4 minus. I'm to find oxidation state of the underlying element, which is what? Which is Mn, manganate ion or manganate ion. To find this, once again, since I don't know that, I'll say let X be equal to this guy's oxidation state, X plus 4 times of O2 minus, and overall is what? Is -1. So I do this, and I get X minus 8 equals minus what? 1. X will be equal to -1 plus 8, and X will give me plus what? 7. That means the oxidation number for manganate ion here should be plus what? 7. I hope you understand what I'm saying. Good. Let's try that one. We are finding H2SO4. So we do with H2SO4. H2SO4. Once again, we are finding oxidation number for this. So let X represent the oxidation number for sulfur. So we have X plus what? But how many hydrogen do we have? 2 of them. So 2 times of the X plus sulfur. Sulfur's oxidation number is plus 6 here. So we have 6 plus, then plus 4 times of what? 2 minus equals what? Equals 0. So this will give me 2x plus 6, then minus 8 equals what? 0. This will give me 2x equal to 2x minus 2 equals what? 0. I'll get 2x equals 2. X will be equal to 2 over 2. Then I'll get x will be what? 1 plus 1. That means the oxidation number for hydrogen is what? It's 1 plus. And that makes sense. That makes sense. Okay. Let's try that of KMnO4. Potassium permanganate. KMnO4. Let's try this. Want to find oxidation number for underlying guy. Potassium's oxidation number is plus 1. So, it's 19. So, plus 1. So, we have 1 plus. Say the oxidation number for magnesium is what? Wait, manganese is what? Is x. So, we have x plus 4 times of what? Of minus 2 equals 0. Okay, let's go. Let's see what we'll have here. This will give me x plus 1 minus what? 8 equals 0. Now give me x minus 7 equals what? 0. X equals what? Plus 7. The same thing we got here for magnesium, although the compound changed by the same thing we have. So this is how we find the what? The oxidation numbers of that. Now let's take what or how to find or how to write the name of what? Of compounds. Now the compounds we are going to write, they come in different forms and they have what? They have different rules. But this is the thing. The question will not tell that write oxidation number for this or that or that. So you have to know how to identify which compound you are naming. Very, very important. So I'm going to show you some of the tricks and some of the things you need to know. Once you see the compound, you can tell which kind of compound you are naming. Hence, you apply that rule or the rule to naming that particular compound. The rule to naming that particular compound. The rule to naming that particular compound. Okay, so the compounds we are going to name, we have binary compounds to name. We have binary compounds we are going to name. We are going to name binary compounds. We are going to name oxoanions. We name oxoanions. We name oxoacids. We name oxoacids. Then we name compounds of oxoanions. Compounds of oxoanions. These are what we are going to name. And in any case, the question will not tell you that, oh, name the following binary compound. Don't say it. Or name the following. No. Nobody is going to say that. But you have to know that this compound written for me is a binary compound. It's what? It's oxoanion or oxoacid or a compound of oxoanion. Then the rule will follow. It's very simple. Good. So let's start with the binary compounds. Binary compound. Let's start with binary compounds. Now, how do I know if a compound is binary? One, the compound binary means that it contains or has how many? How many? Two elements. So I have a binary compound have 2 elements. That's one thing you should take note of. They have 2 elements and they don't have any charge. Their overall charge is 0. So you have something like NaCl. The charge it carries is what? Is 0. So you don't write it. I hope you get the point I'm making here. So that is how we do it. So that is how it is what? It is done. I hope you get the point I'm making here. So when the compound is written for you, we check if the overall charge it carries. Remember I said that SO4 2 minus carries this. So this one cannot be a binary compound. Although it has 2, but it has a charge is not 0. But for these guys, their overall charge becomes 0. So if I give you AlCl3, this is a binary compound, 2 elements, no charge. So this is how you know if the compound is binary or is what? Is an oxoanion, oxoacids or whatever. We are dealing with the binary now. So what have we said? For binary compounds, we should have how many? 2 elements in the compound, and the overall charge of the compound should be what? 0. Now the steps in naming these binary compounds. The steps in naming these binary compounds. Now let's see the steps. Let's go through the steps in naming binary compound. You don't have to choose the steps. You just have to know a binary compound and follow. So I want to use this to name NaCl. The steps are there, so I'll just go through them with you. Step. First of all, write the name of the first element, which I have said that is always what? It's always a cation. Most of the time, they're cations. So what's the name of the first element? The first element here is what? Is sodium. So I write down sodium. I write down the name of the first element, sodium. Then find the oxidation of the first element. Find the oxidation number of the what? Of the first element. But note, if the oxidation of the first element is 3 and above, or the element has a variable oxidation state, write its oxidation number. I explain what I mean by that. You see, there are some elements that have variable oxidation state, and mostly they are from the 30 going. Those guys there, we call them transition metals. So if I give you an example, or it's an example, you know what to do. So the first thing is to write down the name of the first element I've written down sodium. Second one, I'll calculate the oxidation number of sodium. If the oxidation of sodium is 3 or more, or the element I'm calculating has a variable oxidation state, which normally starts outside our 20 elements, then this is what we are going to say. We are going to say that we are going to write that guy or that oxidation number in Roman numerals in parentheses close to this. I'll take an example, then you know what I'm trying to talk about here. Okay, so let's go. So this gives me what? This sodium. Then I calculate the oxidation number for sodium. So I behave as if I don't know this guy's oxidation number. So let X represent sodium's oxidation number. So X plus what? X plus chlorine is here. We know chlorine. Once we can compound, we know chlorine is what? -1. So X plus -1 equals 0. But raw charge is 0. How we get a point? We are calculating the oxidation for the first element is sodium. So I'm saying that let X represent sodium's oxidation number. Chlorine in a compound, we know that is what? It's -1. So we just put the -1 there. X will be equal to what? 1. So this will cross, we get X equals +1. Here, we don't write it in Roman numerals. No. Because we said the only way we write in Roman numerals in parentheses here will be, that this is a condition, will be that the oxidation number to be 3 and what? And above. Or the element we are looking for, or the element whose oxidation number we've calculated, if that element has variable oxidation state, then we have to state that number there to show which particular one we are dealing with. Because if you look at vanadium, vanadium can have 2 plus, it can have 3 plus, can have 4 plus, and can have what? 5 plus. This guy, for instance, has variable, the same thing. Oxidation state what we varies. And I said they are mostly from 21st element or going, but we are in the 20s, so we don't normally bother us unless an element outside that is given to us. Then we can put that guy's oxidation number there. Hope you get the point I'm making here. Okay. So we don't put anything, so this is it. Then chlorine, if you go back here, then consider the next one. The next one says that the suffix IDE or it is replaced with the what? With the last two of the second element. Very simple. Now, chlorine is a molecule and it's an anion, so it becomes chloride. The step says that the last 2 or 3 letters of the second element are replaced and the suffix IDE or DE is placed there. Good. So for chlorine, chlorine becomes chloride. Now, if you go back to the table that we're looking at earlier on, the molecule said chlorine, I said, becomes chloride, fluorine becomes fluoride, nitrogen becomes nitride, sulfur becomes sulfide, oxygen becomes oxide, then hydrogen becomes hydride. So right now, I have named this, and this guy's name is sodium chloride. Let's go through another one. Let's see another one. Let's see how we are going to name this guy. Let's go through another one. Let's take CaH2. First of all, is this a binary compound? That's the first thing we look at. Yes, it's a binary compound. How do we know? We have what? We have calcium and what? And hydrogen. No problem. Calcium and hydrogen. No problem. Now, remember that the second element is an anion, right? And since hydrogen has become the second element here, there's an anion. That will be the hydride. Hope you get a point I'm making, because the first one will be positive. Good. So I write down the name of the first element, which is calcium. This is calcium, the name of the first element. Then the oxidation of the first element is calculated. Let's calculate the oxidation number of the first element. And this is calcium. We don't know calcium, so we'll say let X represent calcium plus 2 times of this time -1. Why -1? Because hydrogen is now playing the second position. And we said those in the second must be what? Negative. And this overall charge here is what? 0. Okay, so this will give me X minus 2 equals what? Equals 0. So this will give me X equals plus 2. Yes. But we are saying that if oxidation is 3 or more, or you get maybe 2, but you have variable oxidation state, out of our first 20, we write it. But if you look at this guy, this is our last element, the 20th element for our level, and it's 2. So it means we won't write down the oxidation number in parentheses or Roman numerals there. We just go straight away. And hydrogen, I said, becomes what? Hydride. So this will give me calcium hydride. This calcium what? Hydride. Hope you get the point I'm making here. Why calcium hydride? Because of the fact that hydrogen is not negative. The negative hydrogen is what? It's hydride. Okay, so let's go to the next one. Let's try. Okay, so the next element is what? A zinc chloride. Let's see. Zinc. So zinc, we'll say we'll have ZINC, zinc. Then in zinc, what do we say? Write down the name of the first element. Writing down the name of the first element, what do? We find the oxidation number for the first element. We don't know, so let X represent that. We have X plus these 2 times of what? Of -1, because chlorine is -1 equals what? 0. So this will give me X minus 2 equals what? 0. So this will give me X equals plus what? Plus 2. But zinc is not a variable oxidation state. Yes, it's not part of our 20, but also the zinc also does not have variable oxidation state. Therefore, we'll go with zinc chloride. Zinc chloride. Others can say zinc 2 chloride, but let's go with zinc chloride. So chlorine becomes what? Chloride. If it's sulfide, it becomes sulfide. So there are other ones there. You can write the name of those binary compounds, then send it to me in the comment section, and I'll check it for you if it's right, so that we can get what? That kind of interaction. If you still have a question, put all the questions in the comment section, and I'm going to answer them. So today, this is where we end our lesson on this. In our last video, we are going to look at the oxo anions, oxo acids. In fact, once you know oxo anions, you know all this. Once you'll be able to get this, the rest will just follow. So that'll be a very short video on all that. But right now, let's go and sit back and look at the binary compounds, understand what we've done today, then get it right. Hope you are good with this. Yeah. So you know what to do. Share this to your friends. Make sure you subscribe and give a comment that I have what? Subscribe. Once you do that, I'll message you, I'll reply your comment. Thank you very much for joining the class today.